February 20th, 1943, north of Kasserine Pass, Tunisia. Through the periscope of his Panzer IV, Oberleutnant Klaus Brenner watched 5 American Sherman tanks maneuver through broken terrain with movements that violated everything Wehrmacht doctrine said was possible without visual contact. The Shermans were separated by rocky outcroppings and wadis that made line of sight impossible between them. No flags waved from turrets. No dispatch riders raced between positions carrying orders. Yet they moved as one organism, each tank positioned to cover angles the others couldn't see, each crew anticipating threats before they materialized. In Brenner's tank, he struggled to hear his company commander through the crackling static of his Fuji-5 radio. The 10-watt amplitude modulation transmitter, state-of-the-art by 1930s standards, could barely penetrate a few hundred meters when his Panzer was in motion. The interference from his own engine drowned out half the words coming through his headset. Most German tanks in his platoon carried only receivers, unable to report what they saw or call for help. They relied on watching their platoon leader's turret and responding to hand signals. The Americans operated with technology the Germans didn't know existed. Every single Sherman carried frequency modulation radios with crystal-controlled precision, 25 watts of transmission power, and clarity that cut through engine noise and battlefield chaos like lightning through darkness. 8,000 miles from Detroit's assembly lines, the most decisive technological advantage of World War II was revealing itself not in armor thickness or gun caliber, but in invisible electromagnetic waves that connected every American tank crew in ways the Wehrmacht had never imagined possible. What Brenner and thousands of German tank commanders would discover over the next 2 years was that they weren't just fighting American tanks. They were fighting America's first battlefield network, a revolutionary communication system that rendered traditional armored tactics obsolete. The technological gap wasn't measured in millimeters of armor or calibers of guns. It was measured in the ability to coordinate, to share information instantly, to fight as a unified force rather than isolated vehicles. And that gap would prove impossible to close. The transformation began on July 22nd, 1941, when the United States Army standardized 3 signal corps radio sets for all medium tanks: the SCR-508, SCR-528, and SCR-538. While German Panzer forces advanced through the Soviet Union using tactics that depended on radio communication between command vehicles, American engineers were perfecting frequency modulation technology that would render German systems obsolete before the first Sherman ever saw combat. The engineering team at the Galvin Manufacturing Company, later known as Motorola, created something unprecedented. Daniel E. Noble, who had joined Motorola as director of research in 1940, conceived the application of FM technology in military vehicles. Working alongside principal RF engineer Henryk Magnuski, they solved the technical challenges of installing sophisticated electronics in the brutal environment of a tank. Their creation weighed 181 pounds and transformed every Sherman tank into a node in the world's first battlefield network. The BC-604 transmitter generated 25 watts of power, 2.5 times the German FUG-5's output. Operating in the 20.0 to 27.9 MHz frequency range, it provided 10 preset channels with crystal-controlled stability that maintained precise frequency alignment regardless of temperature extremes or combat vibration. The dual BC-603 receivers in the SCR-508 allowed commanders to monitor multiple frequencies simultaneously, a capability that would prove decisive in combat. But the real revolution lay in frequency modulation itself. Edwin Howard Armstrong, the brilliant but tragic inventor who had served with the American Expeditionary Forces Signal Corps in World War I, had developed wideband FM in the 1930s after years of secret research in the basement laboratory of Columbia University's Philosophy Hall. His system varied the frequency of radio waves rather than their amplitude, creating a carrier wave that natural static, an amplitude phenomenon created by electrical storms and engine interference, could not penetrate. In 1935, Armstrong demonstrated his invention at Columbia University, turning on his FM receiver before a stunned audience. A transmission from a friend's house in Yonkers, New York, came through strong, clear, and completely static-free. The audience listened to a live music performance and a series of sounds, a glass of water being poured, a piece of paper being torn, that would have been unrecognizable over AM radio. The military applications were immediately apparent to forward-thinking officers. Major General Roger B. Colton, Chief Signal Officer, made the historic decision in 1938 to employ FM in all future military radios. Armstrong, the Patriot, offered free use of his FM patents to the War Department during wartime, a contribution that would save countless American lives. In a letter dated June 29, 1944, Armstrong described Colton's decision as the most difficult decision in the history of radio which anyone was ever called upon to make. The contrast with German systems could not have been more stark. The few G5 radio, standard equipment in most German tanks, operated on amplitude modulation in the 27.0 to 33.3 MHz range with only 10 watts of transmission power. Range dropped to 2 to 3 kilometers in ideal conditions, plummeting to mere hundreds of meters when vehicles were moving. Every spark plug firing, every electrical motor, every track clanks generated interference that AM systems couldn't filter. Worse still, most German tanks carried only few G2 receivers, unable to transmit at all. In a standard German tank platoon of 5 vehicles, typically only the platoon leader's tank had full transceiver capability. The other 4 could hear orders but couldn't respond, couldn't report enemy positions, couldn't call for help. They communicated through actions, watching their leader's turret movement and responding to what they saw. This communication hierarchy created a catastrophic vulnerability. When command tanks were destroyed, easily identified by their multiple antennae, entire platoons lost coordination. German tank forces fought through rigid command structures necessitated by limited communications. American tank forces fought through flexible networks that allowed any tank to assume command functions. November 8, 1942. Operation Torch brought American armor to North Africa. The 2nd Armored Division's tanks landed near Safi and Fadala with SCR-5008 radios that would soon demonstrate their superiority over German communications. Though the landings themselves proved chaotic, with communications breakdowns plaguing the amphibious assault. Once ashore, the tank radios functioned flawlessly. The Arracourt, despite being the Wehrmacht's most experienced armored force, operated under severe communication limitations. German signals intelligence units intercepted American transmissions and noted exceptional clarity and coordination. The 10th Panzer Division's intelligence section reported that American units maintained communication at ranges where German radios produced only static. More disturbing was the realization that every American tank appeared capable of full transmission, not just command vehicles. The Battle of Kasserine Pass, February 14-24, 1943, provided the first major demonstration of American radio superiority, though tactically it proved a German victory. During the confused fighting, scattered elements of the U.S. 1st Armored Division maintained coordination across 50 miles of battlefield. Tank crews who had never met coordinated attacks warned each other of threats and called for artillery support through crystal-clear FM communications. A captured intelligence report from the battle noted American coordination that German doctrine said was impossible without visual contact. The report completely missed the technological foundation, attributing it to training rather than equipment. This would prove a consistent pattern. Throughout the war, German commanders would witness American tactical capabilities, but fail to recognize the radio advantage that made them possible. September 1943 brought American armor to Italy, where mountainous terrain should have negated any radio advantages. Instead, FM technology proved even more valuable. The SCR-508's frequency modulation handled the multipath interference of mountain valleys far better than amplitude modulation could ever achieve. American tanks coordinated movements through terrain where visual signals were impossible, and German radios failed completely. During the advance toward Monte Cassino, American armored units demonstrated capabilities that defied German understanding. Tank platoons separated by ridgelines coordinated attacks with precision that German doctrine said required visual contact. The 1st Armored Division's after-action reports described routine coordination at distances where German radios produced only static. The German FUG-5 suffered from fundamental limitations beyond just power output and modulation type. Variable capacitor tuning meant radios constantly drifted off frequency, requiring manual adjustment. The American crystal-controlled system maintained rock-solid frequency stability. German radios, powered directly from vehicle electrical systems, picked up interference from every electrical component. The SCR-508's dynamotor power supply provided stable, filtered power that eliminated electrical noise. Even the physical design revealed American advantages. The SCR-508 operated on either 12 or 24 volts, automatically adjusting to available power. The BC-606 intercom system integrated seamlessly with the radio, allowing all crew members to alert the commander to threats using throat microphones and noise-canceling headphones. Many German tanks lacked intercoms entirely, forcing crews to communicate by touch or shouting over the engine roar. June 6, 1944. D-Day. As Sherman tanks rolled off landing craft at Normandy, their SCR-508 radios maintained contact with naval fire support, coordination impossible with German technology. The hedgerow fighting of Normandy revealed both the power and a critical limitation of tank radios. They couldn't communicate with infantry radios operating on different frequencies. The infantry's SCR-300 operated on 40.0, 48.0 MHz, incompatible with the tank's 20.0 and 27.9 MHz range. American innovation solved the problem within weeks. Tank crews mounted EE-8 field telephones and ammunition boxes welded to tank exteriors, wired directly to internal communications. Infantry could literally pick up a phone on the back of a tank and talk to the crew inside. By Operation Cobra in late July, this simple modification had revolutionized tank infantry cooperation. German forces never developed an equivalent system. July 25-30, 1944. Operation Cobra demonstrated the full potential of American radio superiority. The 2nd Armored Division, commanded by Major General Edward H. Brooks, coordinated over 200 Sherman tanks through radio networks that enabled unprecedented battlefield control. German defenders from the Panzer Division faced an enemy that seemed to possess supernatural awareness. American tanks responded instantly to threats reported by other units miles away. Artillery strikes, coordinated through tank radios, arrived within minutes of target identification. Panzer, once Germany's premier armored division, had been reduced to communication poverty by mid-1944. Most tanks operated without radios, depending on visual signals in terrain where visibility rarely exceeded 100 meters. The few functioning radios suffered from interference and limited range that prevented effective coordination. The irony was profound. Germany had pioneered radio use in armored warfare. Heinz Guderian, the architect of Blitzkrieg, had insisted on radio equipment in tanks since the 1920s. His book, Achtung Panzer, published in 1937, emphasized communication as essential to armored operations. Guderian had developed the radio communication systems that enabled the lightning warfare that conquered Poland and France. Yet by 1943, German tank production couldn't provide the radios Guderian's own doctrine demanded. The production statistics revealed the crisis. In 1943, Germany manufactured approximately 5,700 medium and heavy tanks, but fewer than 2,000 FUG-5 transceivers. Many radios went to command vehicles and assault guns, leaving regular tank units desperately short of communication equipment. The contrast with American production was staggering. By war's end, all 49,324 Sherman tanks manufactured received sophisticated FM radio equipment, an achievement no other nation approached. September 1944. The Battle of Arracourt provided perhaps the most comprehensive demonstration of how radio superiority translated into battlefield dominance. The German 5th Panzer Army assembled 262 tanks and assault guns, including 107 new Panther tanks with superior armor and firepower compared to American Shermans. German commanders anticipated quick victory against Combat Command A of the U.S. 4th Armored Division. What they encountered instead was coordination that seemed impossible. American commanders could create ad hoc battle groups from different units, confident they could coordinate through compatible radios. Every Sherman could report enemy positions instantly. Tank destroyers received targeting information from tanks they couldn't see. Artillery observers and Sherman command tanks called in devastating barrages within minutes. The flexibility baffled German commanders accustomed to rigid organizational structures necessitated by limited communications. During the 11 days of battle, the 4th Armored destroyed or disabled 200 German armored vehicles while losing only 25 Shermans and 7 tank destroyers. The 7-to-1 kill ratio defied technical specifications. On paper, German Panthers were superior to Shermans in almost every measurable category. But the unmeasurable advantage, the ability to coordinate through reliable communications, proved decisive. Captain Richard Jensen of the 37th Tank Battalion later described the experience in his after-action report. "We could coordinate with units we'd never met, from different battalions, even different divisions. As long as we had the right crystals for their frequency, we could talk to anyone. The Germans seemed to fight as individual tanks or small groups. We fought as an entire division when we needed to." German prisoners interrogated after Arracourt expressed bewilderment at American coordination. Auer, captured Panzer commander from the 111th Panzer Brigade, reported, "They moved like they could see everything on the battlefield. When we engaged one American tank, others we didn't know were there would hit us from different angles. It was like fighting a single organism with hundreds of eyes." The American radio advantage extended beyond just tactical coordination. The SCR 508's reliability meant American forces could execute complex battle plans with confidence. German forces, knowing their communications were unreliable, had to keep plans simple and rigid. Complexity meant chaos when radios failed. American commanders could adapt plans on the fly, knowing their orders would reach subordinate units clearly and quickly. Staff Sergeant Michael Kowalski, a Sherman tank commander with the 3rd Armored Division, later recalled, "You could be in the middle of a firefight, surrounded by engine noise and guns firing, and you'd hear your platoon leader's voice in your headset, as clear as if he was sitting next to you. Meanwhile, we could see German tanks trying to communicate with hand signals and Flag S. It seemed almost medieval." The tactical advantages of universal radio deployment transformed American armored doctrine. The combat command structure, flexible task forces organized for specific missions, depended entirely on reliable communications. German forces observed these flexible organizations, but couldn't replicate them because they lacked the communications infrastructure. Their rigid regimental and battalion structures weren't a choice, they were a necessity, imposed by technical limitations. The production miracle that equipped every Sherman with sophisticated radios represented American industrial mobilization at its peak. Motorola's Chicago factory converted from manufacturing car radios to producing complex military equipment. Each SCR 508 required 2,748 individual components manufactured to exacting standards. The BC 604 transmitter alone contained 474 capacitors and 385 resistors. Crystal oscillators had to maintain frequency stability, despite temperature extremes from -40 to +140 degrees Fahrenheit and combat vibration that would destroy lesser equipment. The statistics told the story of American industrial might. 1942, production, 3,800 SCR 508 family radios. 1943, 11,400 units. 1944, 24,000 units. Total wartime production exceeded 50,000 tank radio sets. This production miracle ensured that all 49 to 324 Sherman tanks manufactured during the war received sophisticated radio equipment. German production of the simpler FUG-5 never exceeded 6,000 units total. The Soviet Union, despite producing more tanks than any other nation, struggled with radio production. The T-34, the most produced Allied tank, typically entered combat without any radio equipment. Soviet doctrine relied on flag signals and pre-battle planning, with catastrophic results early in the war. By 1943, Lend-Lease provided some relief. American radios, including SCR 508 sets, equipped Soviet command tanks. But even by war's end, only about 25% of Soviet tanks carried radios. The comparison highlighted the magnitude of American achievement. While the Soviet Union struggled to equip 1/4 of their tanks with any radios, America achieved 100% deployment of sophisticated FM systems. This wasn't just about having more resources, it was about engineering excellence, production expertise, and understanding that modern warfare required reliable communications. March 1945. As American forces approached the Rhine, their communication superiority reached its zenith. The capture of the Ludendorff Bridge at Remagen demonstrated the speed of American command and control. When the 9th Armored Division discovered the bridge intact, radio reports reached 1st Army headquarters within minutes. Within an hour, divisions across the entire front were shifting to exploit the opportunity through coordinated radio messages that would have taken German forces days to transmit through their compromised communications network. April 1945. The encirclement of the Ruhr Pocket demonstrated the culmination of American communication superiority. American armored columns from the 1st and 9th Armies coordinated a complex double envelopment entirely through radio communications. Inside the pocket, 325,000 German troops found themselves trapped, partly because their communications had collapsed. American fighter bombers, guided by radio-equipped forward air controllers, systematically destroyed German communication nodes. Wehrmacht units lost contact with higher headquarters and each other. After Germany's surrender, American technical intelligence teams evaluated German equipment. U.S. Army Technical Intelligence Report, number 176, concluded German tank communications equipment was approximately 5 years behind American systems. The absence of frequency modulation, limited radio distribution, and poor electrical suppression created critical vulnerabilities that German forces never overcame. Soviet evaluators reached similar conclusions. The Red Army, given access to captured German equipment, chose to copy American radio designs rather than German systems for post-war development. The principle was clear. In modern warfare, the force with superior communications will defeat the force with superior weapons. The network defeats the platform. The connected overcome the isolated. The story of Sherman tank radio superiority represents a revolution in the electromagnetic spectrum that proved more decisive than advantages in armor or firepower. German tank crews fought their war partially blind to this revolution, discovering too late that every Sherman tank was not just a fighting vehicle, but a node in history's first battlefield network. The SCR-5V8 radio transformed the M4 Sherman from an adequate medium tank into a component of a weapons system that included every other American tank on the battlefield. This connection created a collective intelligence that no individual German tank, regardless of superiority in armor or firepower, could match. German forces discovered this reality through bitter experience across 3 continents, learning too late that Americans possessed not just numerical superiority, but technological superiority in the dimension that mattered most: the ability to fight as one. Field Marshal Wilhelm Keitel's reported comment at Germany's surrender captured a fundamental truth. We knew how to build better tanks, but you knew how to make them work together. Whether the quote is accurate or apocryphal, the sentiment reflected reality. America had built not just 49th 324 Sherman tanks, but 49,324 nodes in the world's first armored battlefield network. The revolution in military affairs that historians identify with modern network-centric warfare actually began in 1942, when the first Sherman tank with an SCR-508 radio entered combat. From that moment, warfare changed forever. The side with superior communications would defeat the side with superior weapons. This transformation occurred largely invisible to German forces. They saw American tactical superiority, but didn't recognize its technological foundation until far too late. The German military's failure to recognize and adapt to American communication superiority stands as one of World War II's great intelligence failures. Despite countless battlefield encounters demonstrating American coordination advantages, German leadership never prioritized solving their critical communication weakness. They continued building superior tanks that fought as isolated individuals, while American forces built adequate tanks that fought as coordinated teams. In the end, the electromagnetic waves carried by SCR 508 radios proved more powerful than the armor-piercing rounds fired by German 88mm guns. The ability to coordinate, to share information instantly, to fight as a unified force rather than as individual vehicles, this invisible advantage determined victory more surely than any visible superiority in armament. The Sherman tank's radio superiority changed warfare forever, establishing the principle that, in modern combat, connection equals survival and isolation equals defeat. German troops discovered this reality on battlefields from North Africa to the Rhine, learning through hard experience that fighting Americans meant fighting an enemy who could see everything, coordinate instantly, and respond as one organism to every threat. No amount of armor or firepower could overcome that fundamental disadvantage. The lessons learned proved enduring. Modern main battle tanks carry communication suites that trace their lineage directly to the SCR 508. The technology is digital rather than analog, satellite-linked rather than line of sight, but the principle remains unchanged. The connected force defeats the isolated force, every time a modern tank commander coordinates with supporting units. Through crystal-clear digital communications, they benefit from innovations pioneered by Daniel Noble, Edwin Armstrong, and thousands of American engineers who understood that modern war would be won, not just with guns and armor, but with invisible waves of electromagnetic energy connecting warriors across the chaos of battle. If you found this deep dive into World War II's secret weapon fascinating, make sure to like this video and subscribe to our channel for more untold stories from history. Hit that notification bell so you never miss our next exploration of the technology and tactics that changed warfare forever. Thanks for watching, and we'll see you in the next one.